delay is now on the train because Alice agreed to send her pulse later than Charlie did. We're trying to find by how much they have to do that. So we have to divide both of these distances by c. So we can call these time periods as measured on the train TAB prime and TBC prime minus TAB prime. And we can just open these parentheses to make it simple. So we have LC plus LV. So from this, we get that the answer is 2LV over c squared. This is an important formula because now the rear clock in the frame that is moving relative to the observer is always ahead given by this formula. So, as I've mentioned, notice that it depends on the distance between the clocks. Alice and Charlie are separated by 2L, and that's what we have in the equation.
Don't get me wrong, the
fact that the rear clock is ahead in the other frame is usually what is forgotten when people run into paradoxes and get confused. So this will prove very useful when we are solving problems later.
Don't get me wrong, this guy's math is immaculate. I'm not saying his math is wrong. I'm not saying his math is spot on. Everything his math said is perfectly true. How he interpreted that math is insane, okay? And not all of his math is true, okay? Because he's not following the main thing that he should follow, which is screw Einstein's postulates and worry about the universe's postulates, because they're the only postulates that's going to come true no matter what. And the one true universal postulate is that photons move through space at c, relative to space, not to people, not to your feelings, not to your frame, to space time. He's not using that postulate. He's throwing it in the garbage. He's worshiping at the altar of freaking Einstein instead of the altar of the universe. Let me tell you, the universe is more powerful than Einstein, okay?
Okay, so if all of this seems confusing now, as I've said, don't worry, it is. On the next video, we will equip ourselves with space-time diagrams and Lorentz transformations, and everything will fall into place.
Yeah, it'll all fall into place mathematically. Yeah, as soon as you get your 4D math out and your fake 4D math, do this crap. All right, now you've seen his version of simultaneity. Let's talk about my version, okay? I might be wrong, okay? I'm not saying I'm right. I'm just saying at least mine makes at least some kind of sense. You know what I mean? I may not follow Einstein's postulates, but I sure do follow the universe's postulates. All right, you morons.
So, thanks for watching, and I'll see you there. Before I end this video, I wanted to note that Einstein in his 1904...
And this is more in depth on YouTube if you want to watch his thingies. I'm sure he has good videos, but he doesn't know shit about relativity. I'm sure he learned it the way I learned it, so he has it spot on. Of course, I was a moron when I thought this way, so you know what I'm saying. So, all right, first I have a couple questions about what he did. Right? Why does he measure? Why does Bob, the B guy, right in the middle, why does he measure the photons at the speed of light? Okay. The second question is, why do they have c, right, relative to, the speed of the photons? Why do they have that relative to people instead of space-time? Okay, these two questions are pretty much the same, right? Why are they doing that? Why are they, the universal, they're putting Einstein's postulates above universal postulates, okay? There's a universal postulate we know is a fact, okay? You can't change it, okay? We already saw the equations and blah, 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 okay? Light can only travel at the speed of c through space-time, okay? So right here, you're a big liar, right? You're saying these light rays or photons are moving at c relative to these people that are moving half c relative to space-time. That's your first mistake. That's your first lie. Okay? B, right? Where's B? B sees speed of light at c, right? Which D sees length contraction to make light move at c. Okay? So they're saying that the inertial observer standing still, right, sees length contraction, and that explains why light isn't moving at c in her frame, right? Because if it's moving at c in the moving frame, then it's not moving at c in the still frame, right? So to make up for this, they're going to just say the entire universe. Only in certain universes, though. We all live in different universes depending on how fast we're moving. It's just different universes, you know. He never explains why he makes this c relative to the people on the thing. Okay? Because if what he's doing by doing that, he's saying that c coming out of A going to B is going c plus the moving thing is going half a c. So the light is moving 1.5 c relative to space-time. And the universal, screw Einstein, the universal law says that ain't true. And then he's saying on the other side, with c going to B, it's going c that way, but they're moving in the opposite direction, so you have to minus that. So it's moving, photons are moving half c relative to space-time. Yeah, okay. You're using logic. You're lying. You're putting Einstein's postulates. You're trying to jam these theories down Einstein's postulates instead of caring about the main postulates that are universal, okay, that can't be changed. So they did this lie about this length contraction because the math works out. So what? It doesn't mean it's length contraction. Simultaneity needs to be agreed upon by all frames. This D person needs to they shoot him in the head with these photons, right? It hits him same time. This guy has to agree because all inertial frames, hey man, it's only going to be like 0.00000000043 seconds that this guy gets to peek at this. He ain't going to see nothing. You don't have to worry about what he sees, okay? By the time these photons from C and A hit B, B will be way over, he'll be half a light year away. He'll be way, I'm making up numbers, he'll be way, you ain't going to see nothing, okay? You're not going to see nothing, okay? And the second thing is, we saw over here, right? Over here with the lightning bolts, right down here. Yeah, it's not that the length was contracted, see there? The spaceship was moving. He made the space disappear in between these two things. You know what I mean? The clocks, the clock right here isn't moving slower, and this one's moving faster. He's moving. He's seeing this fast. He's seeing this. Same up here. This A is banging right into there. C is running away from D. What are you talking about? They different clocks. That's insane. Then B, the middle guy up here, he got hit at the same time in all frames. But they're just saying the pulses were not emitted simultaneous according to D. This is all perception. The clocks didn't change on this thing here. They're not different. Okay? Then also, there are no physics experiments that you can do to prove what constant speed you are at in all inertial frames, okay? So that means they have to perceive that light is going at c, okay? It does not say the physics are the same, right? It says the physics results will be the same in all inertial frames. They keep taking this word out, results, okay? All right? You're going to have the same damn physics results because, well, we'll get into that. But velocities are fundamentally relative when comparing inertial frames, meaning these two frames. Okay? Because, nobody's standing still. It's impossible to stand still, pretty much, right? And we don't know where standing still is. We don't know what way we would have to go so that we can stand still. So it's just a mathematical construct, okay? But, so we're all relative. We're all moving relative. But there is a standing still spot, okay? They prove it by using this photon clock, right? This is standing still right here. But let's say the photon comes down and you start moving. Now it's going like this. You've made a second longer. See, this gamma is just hypotenuse over vertical line, right? So here's your hypotenuse, the longer line. These two lines, right, you put them on top of each other. Those represent your, well, this is a lie, okay? This is my mistake. I thought this line represents the Planck length, or Planck second, I'm sorry. This is a Planck second, because this is a ratio. You get 1 second here, look how long it's going to take for this second. It's going to take a lot longer. If this is twice as long, it'll take twice as long to have a second. And I said this was the new Planck second, right? Because this is the second standing still, this is the second when you're moving, right? Just like in your synapses. You move, you make, synapses talk to each other. All physics rely on this. Your synapses aren't touching each other. There's a space. They throw photons to talk, right? If you're moving, now they got a longer travel time to go, and this is why gamma is always bigger, 1 or bigger, because the hypotenuse can only be 1 or bigger. That's just a geometrical thing, right? This right here, if you're standing still, your hypotenuse is basically going straight up and down with you, right? It's 1 to 1, right? But if you start moving, now the hypotenuse is bigger, and the more it gets, the more the horizontal line gets, right? They're proportional, right? So that's why it always has to be 1 or bigger, because you can't make, if you go more that way with the hypotenuse, you'll start making your triangle again, you know what I mean? And it won't be 1 to 1. But your hypotenuse, once you're not a vertical line and you start making a hypotenuse, the hypotenuse is always bigger, right? If it's a hypotenuse over a vertical line, that means gamma will always be 1 or bigger, right? But this idea that you have a spaceship and you're going to this next star and the whole universe contracts, but only for you in your universe, that's called magic, okay? That doesn't explain anything. It just explains that you're woke and you believe in magic, okay? There is a place in the universe where you can stand still. We just can't get to it because you'd have to leave the plane of the Milky Way, right? We have a clock like this. It pretty much looks like this because the Milky Way galaxy is barely moving compared to the speed of light, even at 1,000,000 miles an hour or whatever. You know what I mean? It's not. Our thing is still basically up and down. It's barely moved. You know what I mean? But we have a clock like this. We don't have a standing still clock, right? There is if you're standing still, yeah, you can go any direction, and you're going to make the plates, in between our synapses move, right? You're going to have more distance. But once you move, you're direction dependent on time dilation. Like if you move this way, yeah, you're going to make it bigger. But now that it's bigger, if you move back the other way, it's going to make it smaller, right? Like if you started out here and then you went to a star, get bigger and bigger, and it gets smaller and smaller until you went back to your original form, right? So there is a standing still spot, and that is what light is relative. That is what the light is, is relative speed to, okay? Right? Let's pretend that we have a standing still thing, though, because we pretty much kind of do. But let's just pretend, right? Now let's go into what I'm saying, okay? I'm saying this, okay? You got this guy moving, right? I'm saying that this light is moving at c plus v, okay? And you know why I'm saying that? I don't care what Einstein said. I'm not even thinking about Einstein. Only thing I'm thinking about is the universal law that doesn't change because the universe is like God. He tells us what the laws are. And we have only one law by him. And that's that space-time is relative to light at C, okay?